Today it is equations with exponents. And particularly when you have a squared variable in it. For example, this, if you have x squared equals 25. Anybody remember we spent a good long time last year on doing this? In math, there's these rules. We do them all the time. Let's do something like this. If we have x plus 2 equals 8, how do I solve that equation? This one. Calvin?
You could subtract 2.
Right, subtract 2, and you end up with x equals 6. And basically, it's based on the property that in equations, is if you do something to one side, you can do it to the other side, and it's fine. It makes it okay. Whether it be subtracting, the subtraction property of equations, or adding, you could add stuff to both sides, blah, blah, blah. So, looking at this, I want my equation to say x equals something. What would I have to do to x squared to make it just be an x? Not divide by 2, because that would just be cutting it in half. Kelvin?
Would you divide by x?
Yes, but that's not going to get me a whole lot. Is it? If I divide it by x, and I divide by x, I get x to equal 25 over x, and my x hasn't gone away. That's a good thought, though, and it would work kind of-ish. Anybody? How do I get this square to go away, that power of 2? Sammy? Did you say what?
The square root.
Right. What you have to do, anytime you come up with a square, we've done this before, we just haven't talked about it. To get rid of this, you take the square root of both sides. Square root and square root. The square root of x squared is, what number times itself gives you x squared? X. What number times what number gives you 25? 5. Now, here's what the book is going to do, and you must understand this, and we don't talk about this a lot either. There are actually 2 answers to that. Okay? One of them is 5 times 5, does give me 25, but what other number gives me 25 when I multiply it together? Kelsey? Negative 5. So when you come up with an equation that looks like this, you have to do this little math symbol that we do, which is the plus or minus sign. X squared equals 25, then x can equal plus or minus 5. There's actually 2 answers to that. Okay. Now, what about this? What if I have x squared equals 8? And you probably should show this on your homework now because it'll just help you there. How do I get the x to be by itself? I take the square root of both sides, just like we talked about before. What is the square root of x squared? It's x. What is the square root of 8? There is no perfect one, okay, but it can be simplified. You have to be very careful with that. How do I simplify the square root of 8? Actually, I should put, oh no, I haven't put plus or minus yet. Oh, yeah, I do. Plus or minus. What does 8 break down into? The square root of 2 times the square root of 2 times the square root of 2. What happens to those? 2 of them go away and give you a normal 2. I have to keep the square root of 2, and I have to put my plus or minus there. X would equal plus or minus 2 times the square root of 2. When you are given equations that have squareds in them, these things are called quadratics. And that's what we're looking at today, a quadratic equation. Now, so let's do a tougher one, shall we? Because you're very excited about this. How about this? 2x squared plus 7 equals 25. What was that? 2x squared plus 7 equals 25. Solving it just like a normal equation, I want to get x by itself. What do I do first? First, Lutz, I'm not. I don't. The last thing I do is deal with that square root, or square. It's not square root yet. I need to get that, we call it isolated. I need to get that x squared by itself first. The last thing I'm going to do is take the square root of them. So, but I need to do that, Ariel. I'm going to subtract 7 because of the subtraction property of equations. When I do that, I'm left with 2x squared equals 18, correct? Now to get x squared by itself, I do what, Emily Diedrich? Not yet. Got to get x squared by itself. So I got to get rid of the 2 by?
Divide.
Yes, the division property of equations. Now I'm left with x squared equals 9. Here is where you seem like the smart person here, and Jacob, I have to
The square roots of most x squared.
Yeah. Take the square root of both sides, and I'm left with x being what? Who's going to be the first person to say plus or minus 3? Plus or minus 3. Okay. The only time that you don't have to put that plus or minus 3 is when you're talking about a distance. Distance can never be negative, so if you're talking about a square or a rectangle in there, how long its side is, you would never put a minus 3 because you can't have a square whose side is minus 3 inches long. It has to be plus. Oh, good, you ask. Let's do a problem that has that. Check this out. Similar rectangles. If rectangles are similar, what do we know about them? Their sides are what? Now, what's the word that starts with a P and ends with a proportion? No, not perpendicular. Proportional, yes. So if you got 2 similar rectangles and it is 9 centimeters, and you have an X up there, and then you have an X over here, and this one's 16 centimeters, how do I find out how long those lengths are? If they're proportional, what would I do? You make equal fractions, and it works like this. The short side, short on the small, over the short on the big, equals the long on the small, over the long on the big. Okay, they have to be equal fractions there. The short on the small is 9. The short on the big is x. The long on the small is x. And the long on the small is x. And the long on the big is 16. That's what it means to be proportional. They make equal proportions. So here's my little proportion. Guess how I solve this? How do I solve that, somebody? Smith said? Yes, yes, more yes. X times x is squared. 16 times 9? Yes, it's 144, thank you. And then, Christian, I have to do what? The square root. Look at that. Both sides, square root. Is there a square root of 144? Yes. Yeah. And here is where, like I said, it can't be minus 12. You don't put plus or minus here because it has to be, if it's a positive blank, it has to be x equals 12. You should be relatively unexcited about that. What's that? Did you say you are pretty excited? Yeah, let's do some work